Very, very short. It's only feel how thin the packet is compared to the last packet. Woo! Thin. We are going to be doing a couple more things with Excel or Google Sheets. I call it Excel just because that's the Microsoft Word version of it. So Google Sheets / spreadsheets, we're going to be doing some more work with that so you can become more literate and skilled in that. The more you do it, the better you get. So the first thing we're going to do, though, is collect some data, because that's what we like to do. And we are going to collect some arm span and height data in inches. So first thing you might want to do is in your Chromebook, there is a Google form in the classroom. Chromebook. And so it's not under the upcoming work. It is in the classwork section, though. So you will need your Chromebook, and you're going to see a cute little Google form underneath Scatterplots and linear regression.
What is that? The first one is inches. No, both of them. Yes. Plus 60. Oh. The second one is about plus 40. I got 68.
Might be a little painful at first. So let's start here. We are going to watch the manatee video in just a second.
I don't want to watch it. I want to watch it.
So it's actually kind of some good. I have good news that goes with it. Okay, so like we said, it's a pretty short unit. We don't use a calculator. I don't think until day 3. Just as what I'm remembering. So. And we are going to do some plotting points by hand. I know it's not that exciting, but we do it. And then we let technology take over our world because it's so much easier and more efficient with technology. But at any rate, today we have some vocabulary and just kind of getting back into what scatterplots and correlation are. So if you want to find page 3, we'll do this part first. We'll do the manatee video. And then I think we have one additional page after that. And that's all the lesson is for today.
Okay.
Okay, are you ready? Ready. All right, so let's just look at what this is. Hey, in a scatter plot, instead of having just one variable and frequency, or having the same variable like in a back-to-back stem and leaf, we have 2 variables, and we're looking at how they have or may not have a relationship between them. All right, so we have plotted points, right? It means we have coordinate pairs. This does not have breaks in either axis, but this axis you can break on both of them because it's basically just you want to zoom into where the points are. All of your measurements were probably somewhere between I'm going to say 58 to 78. I'm making a wild guess here. Height, right? Do we need to look at heights of 10 inches? No. So it doesn't make sense to look at that part of a scatter plot when we're doing that. All right, so let's look at this one and just get some context. You guys all understand carbon dioxide emissions, right? From vehicles, from plants, from all sorts of like commercial plants. Yeah, steak, cows, yeah, they make methane. Anyways, did you like that little move? I don't know. Ready? My kid is 10. It's a lot of farting going on in that room. Anyways, then we go back here. GDP. GDP, do you guys know what GDP stands for? Anybody? GDP. Gross domestic. I spelled it wrong. Domestic product. Essentially, it's the wealth of a country, right? GDP is one of those like population GDP. So those are like big facts. So now let's think about this. Hey, I have a country that has a gross domestic product of 1 million and their CO2 emissions are around 200. Oh yeah, thank you. 1 trillion. Their CO2 emissions are 2 millions of metric tons. If I have a country that has a gross domestic product of 5 trillion, notice how much higher their emissions are. Well, why? Because they are producing more, they are exporting more, they have more factories, they have more people, they have, you know what I mean? Like, does it make sense that has a positive association, right? Increasing. Okay. Now the GDP is on the x-axis, which, you know, in science and in math we sometimes call the independent variable. Independent. But we also call it the explanatory variable. Because the GDP may explain what's going on with the carbon emissions. Okay. And then the y-axis, which is another variable, it's not frequency. This is our dependent variable often in science, that's what we call it, right? But we also call it the response variable. Because it is responding, like in response to the GDP, this is what's happening. Okay. Now, scatter plot is just data. It's not really ever going to be perfectly pretty, but could you put your straight edge down and draw a line that runs through it? Sure you could. So if you took your straight edge, you're kind of like checking to see like, that doesn't, you know, I want some points above, some points below, and, you know, maybe it goes there. Like, that's my guess, right? I'm just eyeballing it. The only reason why we would want the y-axis and the x-axis to the y-axis to go, no, x-axis to go back to 0 so we could get a y-intercept. This certainly looks like a linear association, right? And that's what we're going to be focused on in this unit, but you can have associations or patterns of any type. But there might be no pattern whatsoever. All right, so let's get to our vocabulary. Kind of did some of it already up here, but just pulling it all together. Bivariate data is not what we did in the last unit. Even though we had Babe Ruth and Barry Bonds, we were only looking at their home run data. That was one variable statistics, right? That's what you did in the calculator. Bivariate is two variables. It is paired data. As in XY pairs. And that also means that we don't sort it in our calculator the way we sorted data before. Because in our calculators, our data doesn't hold hands with the column next to it. Does that make sense? Like in our spreadsheets, they stick together if we give it the correct command. But the problem with sorting is that you have to be careful that you don't mess up and mix up all your data. Like, for example, if I have your first names in one column and your last names in another column, and I only highlight the last names and sort alphabetically, then the first names are not necessarily hanging on, right? And so we're going to get name pairs that don't go together. Okay, so sorting in our calculator is kind of a no-no for this unit. So what our scatter plot pretty much is our only graphical display that we use. We do not connect it. We don't connect the points. There's a graph called a time series where you do connect the points because it's chronological and you want to see what's going on possibly, okay? Here we do not connect the points. They're just all there. All right. We said our explanatory variable is the x variable. And then our response is the y variable. Notice that it's still in alphabetical order. E-R, right? Anything to help us remember. An association. So that's one of the reasons why we do scatter plots, is we look to see, is there a relationship or pattern between the variables. And then because we're mathematicians and statisticians, we need numbers to tell us how strong things are. Like, yes, we can make a visual observation, but is it stronger than a different association? Is it weaker? So then we calculate something called the correlation coefficient, and it's the variable r, lowercase r, not an uppercase r, lowercase r. And it's just like slope is a number that describes steepness. Correlation coefficient is a number that represents it's going to represent two things: the strength and direction of the association.
Is there a reason that it's a lowercase r, or is that just what they chose it to be?
It's what they chose it to be.
Okay.
Yeah. A lot of variables are lowercase, right? So X bar. It's not a Greek symbol this time though. Woohoo!
Yay.
Yay! No Greek symbols. At least not at the moment. So then there's this idea of causation. Okay. So causation is the idea that there's a reason aka a cause, right? That creates the association. And sometimes in our multiple choice questions, we read too fast and we misread this word. So sometimes instead of the word causation, it will say causal. So it'll be like, is it a causal relationship? Does one thing cause the other? But when people look at that word too fast, they see the word casual, don't they? Right?
Well, it looks like casual.
Yeah, it definitely looks like casual. Just two letters being moved. All right, let's go ahead and turn the page. So this is our Against All Odds video. Our main character is a manatee. So what is a manatee?
An animal.
Yeah. There's going to be doing a relationship. And so so while the context of this video might be a little bit like downhearted, woo, it's between the number of powerboats registered and then the unfortunate number of manatees killed. So we're going to look at that relationship in a scatter plot form. Then we're going to talk about why the horizontal axis is different than the vertical axis. And the last thing is, what would we expect to see with a negative association, which that should then key you in that there's this thing called a positive association. Dun, dun, dun. All right, are we ready for our video? Bring it on. Okay. So I lost her. Here I am. Okay, let's lower up and start back at the beginning.
It's against no all.
It's against all odds.
Nope, there's not.
There are.
Hi, I'm Party Sabetti, and this is Against All Odds, where we make statistics count. Manatees. These slow-moving sea creatures lull and munch their days away in the warm waters off the Florida coast. They have a certain lumpy cuteness to them, but it must have been wishful thinking that made early European explorers mistake manatees for mermaids. These gentle giants can weigh more than half a ton, And since they're mainly herbivores, they keep their weight up by feasting on underwater vegetation in shallow coastal waters. They pretty much have no natural predators. That doesn't mean they don't face any threats, though. Human-related fatalities are a major contributor to manatees' endangered status. Their inquisitive friendliness and their tendency to hang out just under the water's surface can put manatees in the direct path of motorboat propellers.
This manatee here is using a line that we call the dental flossing line for manatees. If you're not real careful when you start your motor, you could inadvertently end up injuring one of these beautiful animals.
Many collisions are fatal, and almost all adult manatees are crash survivors, which you can see from the propeller scars on their bodies. In the wintertime, Florida manatees congregate in warm water areas like the waste heat outlet channel of this power plant. Officials know where manatees are likely to be and impose speed limits on boats to try to protect the marine mammals.
Skipper, take your boat out of gear. I'll be coming on your port side. Y'all gonna have to be more conscientious of this manatee zone. That's too fast in there. I know you don't want to hit one of them. I'm sure you don't want to do that, all right? Watch your water. A good way to tell is you look at the back of your boat. If you're peeling off that white water off the back of the boat, it's too fast.
Even with these precautions, researchers noted back in the 1980s that manatee deaths were rising every year. But why? Were people or manatees behaving in different ways than they had in the past? Statistics to the rescue. Statistics can help us take a closer look at the relationship between all those motorboat propellers in Florida waterways and manatee fatalities. The number of deaths and the number of powerboat registrations are both quantitative variables. That means they can be measured numerically, and we can plot their values. Instead of looking at a single variable, like we did using stem plots and histograms, we can create a scatter plot to consider the relationship between these two variables. Here we have the data on boat registrations and manatees killed by boats every year from 1977 to 2011. To make a scatter plot, we first draw horizontal and vertical axes. But which variable should we plot on which axis? We suspect that the number of powerboats in the water helps explain the number of manatees killed. So we call the number of powerboat registrations the explanatory variable. And the explanatory variable always goes on the horizontal axis. Here, that's powerboat registrations, which we're showing in thousands. We expect that the more boats that are in the water, the more manatees will be killed, all things being equal. Or to put it another way, we assume that the number of manatees killed is a response to the number of boats in the water. So we call the number of manatees killed the response variable and plot it on the vertical axis. In 1977, the number of registrations was 447,000, and the number of manatees killed by boats was 13. In 1978, there were 460,000 registrations and 21 manatees killed. We keep plotting the points for all the data we have and come up with this picture. What does the scatter plot tell us? The data confirm our suspicions. As boat registrations rose, so did manatee fatalities. See how the pattern goes from the lower left to the upper right? As one variable increases, so does the other. This is called a positive association. Not positive for manatees, of course, but positive in a statistical sense. A negative association would be when one variable increases while the other decreases. Learning a skill is a classic example of a negative association. Think about the relationship between, say, how long it takes you to make a pie and how many times you make one. As the number of times you've baked your award-winning pie increases, the amount of time it takes you to create each pie decreases till you've mastered the skill. So we say that these two variables exhibit a negative association. There's another feature to note in our manatee scatter plot. The points roughly fall in a line. We call this pattern linear. Of course, all the points don't fall exactly on a perfect straight line because this is real-world data, and reality is rarely so cooperative. But within the realm of statistics, this scatter plot is certainly linear. In fact, since the points don't deviate much from a line, we can say that the linear relationship is strong between boats in the water and dead manatees. If our data were all over the place with lots of deviations from the line, we would call the relationship weak. Keep in mind that not all relationships are linear. Some relationships show a curve pattern, like this one, where the variables start out increasing together, but one speeds up. Or maybe there's no pattern at all. When you're looking at a scatter plot, you'll want to think about the overall pattern, how strong it is, and its direction. Keep your eyes peeled for deviations from the pattern too. Outliers can hold important information about your data. A scatter plot can show you the nature of a relationship between two variables, but it definitely doesn't prove why the relationship exists. The changes in one variable don't necessarily cause the changes in the other. Back to our old buddies, the manatees. Rather than more boat registrations causing more manatee deaths, I can imagine lots of other factors that our scatter plot doesn't take into account that could tell a different story. Maybe the years with more deaths happen to be cooler, so manatees cluster even more than usual in the warm water areas where boats are. Or maybe there's an unrelated manatee disease that happened to flare up during the years that boat registrations were higher, that made manatees sluggish and less able to get out of the way of motorboats. But identifying this relationship is a start, and provides enough evidence for the state of Florida to think more about how to protect manatees from those deadly propellers.
The problems the animals face are directly related to the growth of the state, and we have to accommodate the animals as we accommodate the human growth. And they're extremely adaptable animals. They're tough, they're resilient. If we just give them a chance, I think we can keep them around.
I'm Party Sabetti for Against All Odds. See you next time.
Manatees! All right. This is Miss Rob. No, what's up? Yes. Study hall time 11:50. Okay. Yep. Okay, very good. All right, so manatees, reptiles, fish, what are they?
Mammals.
They are mammals. They are mammals, and that's really important because mammals are warm-blooded, right? And so they need that warm water, which is why they're in the inlets and not necessarily out in the ocean. Okay, so they are herbivores too. They eat that. And they might weigh a little over a half a ton. Well, how big is that? Who knows anything about tons? Not 500. 1,000 pounds. So a ton is 2,000 pounds. And so it's kind of an old archaic way of measuring things rather than kilograms and such. But basically, as you drive around, especially when you go over bridges, you'll see like 5 ton maximum, etc. All right. So now our scatter plot. What did our scatter plot show? So we had points kind of going like that. This was our powerboat registrations. Boat. And then this is our manatee deaths, unfortunately. And there was this positive association. But I think it's really important what she mentioned at the end, that just because there's that association there, it just warrants us going deeper into finding out what's happening. It might not necessarily be just the fact that the powerboats have increased in registration. That's the reason why the manatee deaths have increased. All right. So then, why was the powerboat placed on the registrations placed on the horizontal axis? Is because the hope was that maybe the powerboats explained, right, the deaths, and so that's that idea of the explanatory, the response. And so of course then the deaths were the response variable. Okay, so it does get, I will say, like on multiple choice questions, I'm going to be using those words, explanatory and response variables, and so you have to know which one's which. It is alphabetical. E goes with the x-axis. And look at the second letter's an X. Woo! Okay, so what trend would you expect to see if we have a negative association? So yes, in simple terms, it goes downhill, but that's not how we actually explain it. Okay, we talk about as the explanatory variable increases, the response variable decreases. So another example of this is like thinking about my own automobile. As the mileage increases, the value, the monetary value of my car, its resale value decreases. I'm at 91,000 miles, going strong. Woo-hoo. Honda, I need it for life.
What kind of Honda?
CRV, man. I used to do Civics, but then, with the kid. And I'm not a minivan person. No
My
minivan.
dad has a minivan.
No.
131.
He looked like he had stock in one.
131? Nice. All right, so let's go ahead and turn the page, and then we'll do this page. But before we do this page, we'll quickly just talk about marine life in the news. So first thing is, and this goes from last January. So we'll have an update this January. We don't have it yet. We'll have to wait like a month and a half. It was Manatee Monday. Woo-woo! Manatee Monday in Volusia County, Blue Spring State Park in Florida. And this was January 6th of this year. And so this is like an inland, somehow they must get inland for the winter. And it's great because it's a protected space. And so the current count of manatees is 804. That was as of January this year, past year, or beginning of the year.
Everywhere?
And no, just in the park.
Oh.
So it's been a protected space, state park since 1972. And so in wintertime, the manatees come into the park, like there must be a waterway to get back in there. And they like it because it stays a fairly consistent 72 degrees of being a mammal, right? You need the right temperature water or you won't survive. And so it's north of Orlando, so I threw in that because I had no idea. But basically there are, and we've seen quite a few biologists, right? In these videos, when we're talking about nature, all those people have some sort of ecology, biology degree, and they're helping to track populations of animals that may or may not be an endangered species. We do types of association. So if we look at these first two, these are kind of typically what we will see when we do scatter plots. Can you guys all imagine a line going uphill on this one? And a line going downhill on that one? So this is linear and positive, a positive association. This is linear and negative. When we get to correlation coefficient, then we can talk about strength, weakness, moderate associations. We aren't going to worry about the strength piece just yet. All right. But as Party Sabetti mentioned, they can come in all sorts of shapes. You might have a scatter plot that looks completely random, which means there's no association. Okay. I don't have a great example for this one, but this is what I will come up with. I think I was. All right. So if you kind of look at this, you could actually make this kind of graph going on it. Yeah. So it looks like stairs, doesn't it?
Yeah.
So it's called a step function when we actually have this. And the one thing I can kind of think of that has this, and I don't have great variables for the axes, but I like to think about how when my son was playing recreation soccer, he was in U5, right? And so there was a whole bunch of kids with different, I don't know, heights and weights. And then they all went to U6, right? And then they all went to U7. But they didn't all perfectly match, right? But they were in these step categories based on their age, their birth year. All right, so now let's go ahead to two more that we might see. And these are, I think, our last two before we get done today. All right, so this one kind of curves and flattens out. That is exponential. Yeah. Well, the next one is more roller coaster. Exponential. And this one kind of follows a decay pattern. And actually, this is kind of a pattern that happens with cars. They lose value quickly sometimes, and then they kind of flatten out depending on the mileage. This one, which everybody should hopefully be able to name and be familiar with, right? What shape is that?
Unicorn.
Oval.
Not an oval.
Rainbow.
Not a rainbow. I'm hoping we go with some math terms. There's one. There.
It's a curve.
Thank you. Parabolic. Yep, parabolic.
I don't know what that is.
Okay, so algebra 1, algebra 2,
I forgot.
parabolic or quadratic.
Oh, okay. I know what quadratic is. See, if you just said quadratic.
Well, excellent. Quadratic. Hi, anytime you throw a ball in the air, people,
Yeah.
this is what you get. Okay? Like literally. So we will stop there. And there's no homework for tonight.